Okay, so we're looking at indices today. So before we do our two examples, we'll just have a quick look at the rules of indices. There's 9 of them I want to go through. First rule, a by m multiplied by a to the power of m multiplied by a to the power of n. We add our indices. So for example, 5 to the power of 3 by 5 to the power of 6, 5 to the power of 9. We do the opposite when we're dividing. So a to the power of m divided by a to the power of n, we subtract their powers. So that means 3 to the power of 7 divided by 3 to the power of 5. 7 take 5 is 2. So that's how we get that. Anything to the power of 0 is 1. So 27 to the power of 0, 1. In this situation where we have brackets, a to the power of m, and then we have an n outside, we multiply our powers. So in that case, 3 squared, all to the power of 4. 4 multiplies to 2, so it's 3 to the power of 8. Anytime that you have a minus in front of your power, it means your number is on the wrong side of the line. So it's instead of 8 to the power of minus m means 1 over 8 to the power of m. So for example, 5 to the power of minus 3 means 1 over 5 to the power of 3. Another example would be 3 to the power of minus 2, 1 over 3 to the power of 2. There's just a reverse of that as well. If, for example, if I had 1 over 3 to the power of minus 2, because the minus means the 3 is at the wrong side of the line, so that would be 3 to the power of 2. So the minus just tells you it's on the wrong side of the line. Basically, this is easier explained really over here. 8 to the power of a half is another way of saying the square root of 8. So for example, 4 to the power of a half is the same thing as the square root of 4. If I said 8 to the power of 1/3, that would be the same as the cube root of 8. 8 to the power, let's say 7 to the power of 1/6 means the 6th root of 7. So fractional powers or fractional indices mean they're roots they're talking about. This is an interesting one. Again, I'll explain rule 7 using numbers. So for example, I've got 27 to the power of 2/3. Now, let's remember this is two different pieces. I'm actually going to split this up a little bit, so I'm going to do a better example of that. 27 to the power of 2/3. Well, we'll split it up first. That's 27 to the power of 1/3 squared. So let's have a look at this. Remember the previous example we just did? If we have the power of 1/3, that means the cube root of 27. And then all of that is squared. So all of this is squared. The cube root of 27, what number multiplied by itself 3 times will give me 27? Well, that's the number 3. And then 3 squared is 9. A times b to the power of m means both of them go to the power of m. So I'll just do a couple of examples of that to the right. So for example, if I had xy to the power of 2, that means both of them get squared. So if I have 3 times x to the power of 3, that means both of them get cubed. And when you put in 3 cubed, 3 times 3 times 3, that's 27, x cubed. So the example they have here is, if I have 3 root 2 to be squared, well, both of them have to be squared. The 3 is going to need to be squared, and the root 2 is going to need to be squared. So that's 3 squared multiplied by root 2 to be squared. 3 squared is 9, and root 2 squared is just 2. So 9 by 2, 18. And finally, if you have a fraction to a power, both the numerator and the denominator go to that power. So for example, here it's 2 over 3 to the power of 3. That means the 2 has to be cubed and the 3 has to be cubed. 2 cubed means 2 by 2 by 2, which is 8. 3 cubed is 3 by 3 by 3, which is 27.